And what we're going to be doing is we're going to take a look at this equation and we're going to do something like this. So the first thing it's going to do is we're going to ask how tall is the cliff. So that happens when t is equal to 0. And if I look at the original standard equation, we know that this is our h-intercept. So that means that our height should be 35. So if you just tell me right away that it's 35, then you're good. 135, then you're good. So in this case, we're going to say h is 35 meters is the height of the cliff when we start. Now, our original equation asks us what is the maximum height of the rock and when does it occur. So what you're going to have to do is you're going to have to go and do this problem by completing the square. So the first thing that we're going to do is we're going to start with our objective function. Then we're going to isolate just everything that has a t or t squared. The next thing that we're going to do is we're going to factor out a negative 5. So we end up with this sentence. Now you'll notice I've underlined negative 6. So in order to complete the perfect square in this bracket, we're going to have to take 6 divided by 2, square it, and that will give us our final answer of 9. Now, once we've done that, we put our 9 and negative 9 inside our bracket. And then we still have our plus 135 on the outside. Now, what's offensive to us is that minus 9 that's sitting in the bracket. So we're eventually going to move that out. Now, when we do that, we're going to have the following. We're going to have t squared minus 60 in the brackets, plus 9 in it. And then we still have our plus 35. But now we have a bracket that contains all the junk that came out of the from the bracket. So we got a minus 5 from the bracket and a minus 9, which gives us a total of 45. When we simplify, inside the bracket, you're going to have this. T squared minus 60 plus 9. And then you're going to have plus 135 plus 45. And then when we simplify again, our final bracket is going to look something like this. And inside the bracket, we're going to have t, and it should be a minus 3 because we're taking our minus sign from the previous center piece in our bracket, and we end up with this. So therefore, our max height is 180 when t is equal to 3 seconds. So now, what we have left is calculating the height of the rock after 1 second. So normally what you do is you just plug t as 1 into our equation, and you end up with something like this. H is 160 when you simplify. So you'd say, hey, the height is 160 meters when t is 1 second. Now, you could do the same thing for 5 seconds as well. It's not necessary, but just use the symmetry of your parabola, and you'll notice that your height should be 160.
Good morning, Shepherd.
And now when we're trying to find our intercepts or our points that, so when it asks for how long does it take for the rock to hit the ground, what we're asking for is the intercept form. Or when our h value is equal to 0. So we're just going to follow that same pattern that we did before. So you start with your basic function. So what we're going to be doing is we're going to let all this equal 0. And when we do that, we get something that looks like this. So we pull out our minus 5, and we end up with t squared minus 60 minus 27. So we're looking for something that multiplies to negative 7 and adds to negative 6, which ends up being negative 9 and 3. So we end up with something like this, negative 5, t minus 9, t plus 3. And when we solve, we end up with x is 9 and x is negative 3. Now, x is negative 3 is erroneous because if you think about it, our t values, not x values, are greater than or equal to 0. And ends up being t equals 9 or t equals -3. And -3 is erroneous because our t values must be greater than 0. So we could say right off the bat that, therefore, it takes 9 seconds for the rock to hit the ground. And we're done. Now, your homework for today is based on some extra questions that look like this. So, for example, 3, Helga owns a playground, right? And on this campground, she has a pool, which is measured by 20 by 10, okay? And what we want is the deck to be a certain amount, and we have a restriction of how much she can pay. So first of all, we need to calculate the area that's used for our walkabout area. So we're actually going to take the area of the big square, subtract the area of the small square. So if you think about it, the reason why we have 20 plus 2x and 10x plus and 10 plus 2x is because the width of this side is x plus 20 plus x. So you end up with 20 plus x. And the same can be said about the width of our bigger square, which is 10 plus 2x. So now we end up with a is equal to 40 plus 20x plus 4x squared minus 200. And that's just the expansion of the first bracket and the small area, which is 20 by 10. Now, simplifying, you end up with a is equal to 4x squared plus 60x. Now, in order to figure out how much she can pay for, we know she can pay $19.20, but the cost per meter is $30 per meter. So when we do this problem, we have to take our money, and then we have to take the ratio and we have to flip it. Otherwise, we're literally, the other way of doing this would have been taking the ratio and dividing, taking the money and dividing by the ratio. So you end up with, in this case, the way I'm doing it, you end up with 1920 times meters squared over 30 instead. So now if we go and cancel, we end up with our final answer to be 64 meters squared. So she can literally afford to pay for 64 meters squared of stuff. All right, so remember that our area calculation was 4x squared plus 60x. So what we're literally going to do is we're going to let a equal 64 based on the fact that she can only pay for 64 meters. And now we go back to this equation by taking our 64 and then we move it to the other side of our equation. And now we factor out a GCD. So our GCF. So our GCF in this case is 4. So we're left with x squared plus 15x minus 16. And now what we need is two numbers that multiply to negative 16 and add to 15. And we find out that it's 16 and negative 1. So this simple factorization is going to be this. 0 is equal to x plus 16 bracket x minus 1. Now, what this tells us, each of those brackets could be 0. So when you go and solve, you end up with x is equal to negative 16 or x is equal to 1. Now, one of these is ridiculous. It's impossible because we cannot have a distance for our width being a negative value. So this one here, negative 16, is impossible. Impossible. So therefore, the width of our deck is going to be 1 meter. Now, your homework for today is, first of all, understand that for the big ideas, we've got When you factor something, they give the factors all have to equal to 0, and we solve for it. That's all we're doing. Some quadratic relations can be solved by factoring, right? And that's it. We never called them the roots, but if you think about it, the solutions, the values that give us the solutions to something, we call the roots. Okay? Now, let's move on. This is your homework for the day. All right? Make sure you do at least one of the challenge problems.